Okay, hello everybody. So, in today's lesson, I just really want to try and finish up with expected frequency. So, I know this is something that some of you have been finding very easy, and some of you might have been finding it a little bit difficult. So, I just wanted to make this video to go over a few little things, so that hopefully, if you ever get stuck with this again, you can go back and look at the video, and that can help. Okay, so we're going to look at a few different questions, and then I'd like you to do some questions then as well after the video. So, first thing, let's just go over a few things with expected frequency. So, expected frequency is the number of trials by the relative frequency or the probability, okay? So, the expected frequency of an event basically is how many times we think something is going to happen, okay? So, it's, for example, if you were to flip a coin 200 times, how many heads would we expect to get? If you were to throw a dice 500 times, how many ones would you expect to get? All those answers are the expected frequency of various events, okay? So we're going to look at this question here, right? So it says, one ball is selected at random from the bag shown, so this bag here, and then replaced. And this procedure is done 400 times. Okay, so I'm just going to underline that, 400 times. And the first question says, how many times would you expect to select a blue ball? So the easiest thing to do with these questions is to ask yourself these two questions here. What is the number of trials and what is the probability? Okay, so in this case here, what is the number of trials? So it tells us that this procedure is done 400 times, okay? So we're going to say number of trials is 400. And now it's asking us, what is the probability? So for our first question there, part 1, it says, how many times would you expect to select a blue ball? So I'm going to say the probability of blue, okay? So in order to find out that probability, sometimes in the question it might tell us, but sometimes we might need to try and figure it out ourselves. So in this case, we need to figure it out ourselves, and we need to look at this bag here. So we want to find the probability of getting a blue ball. Okay, so how many blue balls are there in that bag? There are 2. Okay, 2. And how many balls in total are there? 1, 2, 3, 4, 5. Okay, and to get the probability of an event, it's the number of times that event happens over the total number of outcomes, okay? So the probability of getting a blue ball, there were 2 blue balls and 5 different options, or 5 different balls. So probability of getting a blue ball is 2 over 5. Now we want to get the expected frequency. So I'm just going to say EF. And we know it's equal to the number of trials by the relative frequency or probability. So let's fill out our formula. We know our number of trials is 400, and we know the probability of getting a blue ball is 2 over 5. So we multiply by 2 over 5, and that, if we put that into our calculator, we end up getting 160. So that's how many times we would expect to select a blue ball. Now we're going to try the same thing for part 2 of the question, okay? It says, how many times would we expect to select a red ball? So the number of trials is still going to be 400, as the experiment is still happening 400 times, okay? Now the probability of selecting a red ball. So remember, it's the total number of times the event happens, so the amount of times we get a red, over the total number of outcomes. So we know there's 3 red balls, 5 outcomes, so it's 3 over 5, okay? So then, to get our expected frequency, we do the number of trials multiplied by the probability, and we end up with 240. Okay? Okay, now we're going to look at a similar question, but a little bit different, okay? Still expected frequency. So it says, a fair six-sided die has its faces painted red, white, or blue, okay? As we can see in this picture here. And the die is thrown 36 times. And here are the results, okay? So when it's thrown 36 times, 7 times we get a red face, 11 white comes up, and 18 times a blue face comes up. And it's asking us, based on the results, how many faces do you think are painted each colour? Okay, so this question, it's kind of tricky as it's not very straightforward what we have to do here, okay? However, it's an expected frequency question. It's saying, do we think? So it doesn't say, do you expect, but do you think are painted each colour? It's a similar style question here, okay? Okay, so we have a look here, the number of trials. So in this case here, the number of trials is going to be the number of faces. Okay, so this question is kind of similar to those questions we looked at before, where it's like, if 30% of a class have a dog, how many students will we expect in a class of 30 to own a dog? Okay, it's similar here. We're saying, how many faces on this dice will we expect to be painted each colour? Right, so we're going to say the number of trials is 6. Okay, because there's 6 different faces. Now, the probability that the face is red, okay? So it tells us here that when the dice was thrown 36 times, 7 times it landed on red, okay? So 7 over 36 is our relative frequency or our probability, okay? 7 is the number of times the event happened, so the number of times red turned up. 36 was the total number of outcomes, the total number of times the dice was thrown. Okay, so now to try and find out how many faces do we think are red, we do our number of trials multiplied by our probability. Okay, and that gives us 1.16666. Okay, so we can round that to 1 face. Okay, so we know we can't have 1.1666 faces on the dice. We're either going to have 1 face, 2 face, 3 face. Okay, so 1 face we're going to say is red. Okay, and if you're forgetting how to do that multiplication on your calculator, okay, you can simply turn that 6 into 6 over 1, multiply by 7 over 36. So it's top by top, 6 by 7, and then divide that by the bottom by the bottom. Okay, so it's 42 over 36, which ends up as 1.1666. Okay, now, so we need to do the same thing for the white faces. Okay, so for white, our number of trials is still 6. There's still 6 faces. And the probability of getting white. Okay, so when the dice was thrown 36 times, it landed on a white face 11 times, okay? So the probability or the relative frequency of it landing on white is 11, as that's the total number of times our event happened, over 36. So our expected frequency then, EF, is going to be 6 by 11 over 36, and that gives us 1.8333, which we can round up to 2 faces. Okay, so we now know, we think that 1 face is painted red, 2 faces are painted white, and then we could figure out by process of elimination how many are painted blue. However, we might just do our expected frequency test anyway, just to practice it. So for blue, write this in red, so blue, we have our trials are still 6, there's still 6 faces. probability of blue is 18 over 36, because when they threw the dice 36 times, it landed on blue 18 times. So then our expected frequency is the number of trials, 6, by 18 over 36, which gives us 3, okay? 3 faces. And then 3 faces plus 2 faces plus 1 face gives us 6 faces. And that's our final answers. Now, can you please write this example down into your copy and make it really, really neat. Make sure to include all the boxes, so your green box, your yellow box, and the different steps, so you have it in your copy to look back on in future. Okay, and if you have any questions about this, please send me a message. Okay, we're going to look at another question now, and this is one that you were doing for work last week, or should I say 2 weeks ago when we were in school, and I know a lot of us had some issues with it, so I said I'd go through it really, really slowly, so hopefully it'll clear up any confusion. So it says a bag contains 8 counters. Each counter is blue, red, or yellow. Okay, so blue, red, or yellow. Helena takes a counter at random from the bag. She records the colour of the counter and then puts the counter back in. And she does this 400 times, okay? So it's 400 times. And the table here shows her results, right? So when she did that 400 times, 210 times she got a blue one, 98 times she got red, and 92 times she got a yellow counter. So our first question is, estimate how many of the 8 counters are blue. Okay, so we want to find out how many of those 8 counters are blue. So first thing we ask ourselves is the number of trials. And it might be very easy to go, oh, she did the experiment 400 times, it's 400. But remember, what's the question asking us? How many of the 8 counters are blue? Okay, so we need to figure that out, okay? So in this case, like in our classroom situation where we're trying to find out the number of people in the classroom who own a dog, our number of trials is going to be 8, okay? Because we've 8 counters. Because we're trying to find out how many of those counters are blue. So it's not 400, okay? You have to really read the question. Now, our probability that it is blue, okay? That a counter is going to be blue. That's where we use our 400, okay? So we look up here. And it said when she did an experiment and she took out a counter 400 times, 210 times a blue counter came out. And she did that experiment 410 times. So this is your relative frequency, okay? So remember, it's the number of times the blue comes out, which is 210, over the total number of trials, which is 400, okay? So maybe if you're getting a bit stuck on that, go back over relative frequency, okay? All the notes are on Edmodo. So go back over, how do I get the relative frequency, okay? And it's the number of times the event happens over the total number of outcomes. So now, to get our expected frequency, we follow our formula up here. The number of trials, 8 by 210 over 400. So it'd be 8 by 210 over 1 by 400, and that gives us 4.2, okay? We know we can't have 4.2 counters, so we round down to 4, okay? So that's your answer to the first part of that question, okay? Now we're going to look at the second part of the question, which says, estimate how many of the 8 counters are yellow, okay? Now, let's have a little look at that one. So, once again, we ask ourselves, what is the number of trials? What is the probability? So, number of trials. What are we trying to find out here? Okay, we're trying to find out how many of the counters are yellow. We know there's 8 counters. Okay, so our number of trials is going to be 8. Now, the probability that the counter is yellow. Okay? It doesn't tell us. We have to figure it out from this experiment. So we know that when Helena did the experiment and she took a counter out 400 times, 92 of those counters were yellow. So yellow happened 92 times. So 92 over the total number of experiments, which was 400. Okay? That is our probability that a counter is yellow. Okay? So now we fill in our formula, which is 8 by 92 over 400. Okay? So 8 over 1 by 92 over 400. That gives us 8 by 92 over 1 by 400. And our answer is 1.84. We know we can't have 1.84 counters, so we need to round this number, okay? And that number will round up to 2. Okay, so 2 counters are yellow. Okay, we are estimating that 2 are yellow based on this experiment up here. Okay, so if you see that there's an experiment and a number of trials, and then it tells us the frequency of how many blues there were, how many reds there were, you're going to use that for your probability or your relative frequency, okay? That's not the number of trials. So it's really, really important to read your question. And if you're trying to find out how many of the 8 counters are blue, your number of trials can't be 400, okay? It's going to be however many counters you have. However, whatever you're actually looking to find. Hopefully that helps a little bit. Okay, so we're going to do another example here, just so we have lots of different examples to look back over. So this one is saying the probability of having to wait for more than 5 minutes at a post office is 2 over 7. 350 people use the post office in one day. So work out an estimate for the number of people who have to wait more than 5 minutes. Okay? So this is our expected frequency. Okay, we're trying to find out how many people do we expect will have to wait for more than 5 minutes. So, the 2 questions we ask ourselves: what is the number of trials? What is the probability? Okay? So, number of trials. And we can see here that 350 people use the post office every day. So that's our number of trials, okay? So it's the number of people in this case who are using the post office, because we're trying to find out how many of those people will have to wait more than 5 minutes. So they're the people we're interested in, those 350 people. Now we have, what is the probability of having to wait more than 5 minutes? And it tells us in the question that that is 2 over 7. So now to get our expected frequency, we do our number of trials multiplied by the probability, which is 2 over 7. So we do 350 over 1 by 2 over 7. So then we end up with 700 divided by 7, because remember it's top line by top, bottom by bottom, which gives us 100. And that is our estimate for the number of people who have to wait more than 5 minutes.